Hey folks, happy Monday. Hope you're doing well. Alrighty. Hope you had a nice weekend. The weather wasn't too bad, right? A little bit of rain, that was pretty good. Oh, we don't need that one now. Let's see. What do we need here? Pull up D2L. There we go. Alrighty. So we are cruising along here. We're going to move into Chapter 3 tonight. Oh, cool. Some people already got the next assignment in. Fantastic. And don't forget, this is the last week for Project 1 to get in. You can't hear me? Can you hear me? I'm loco? You got no sound? Looks like I got sound. Okay. All right. Check your mute, maybe? All right, cool. And then quizzes. We had the Chapter 1 quiz. That was due last week. I'll get that one graded hopefully tonight. And then the Chapter 2 quiz due by 11:59 p.m. tonight. Please get that one in. All right, cool. Yeah, a little refresh. Awesome. Project 1 is definitely Chapter 2. Yep, you shouldn't need any of the stuff from Chapter 3 for it. Yeah, I don't think you'll need any of it. If you want to make it smarter, we could, and then we'll talk about that today when we start talking about Chapter 3. What that enables us to do. But all you need is stuff from Chapter 2 for Project 1. Yep. So make sure you get that one in. So this is crazy. So here's the lecture archive. Remember, I linked to the YouTube exports, but you can also watch the VODs on Twitch for about 45 days or so. So we are in week 3 already. Wow, it is going by quick. Let's see. Here we go. Yep, week 3. Remember, we're off next week for Memorial Day. Maybe we don't need the project due that day then. Was it due 6/7? Is that what that is? Did I do that right? Forgot Memorial Day's coming up. That's next Monday. Wow. May's almost gone? Let's see. When is that? Oh yeah, okay. So it is June 7th. I'm sorry. So yeah. June 7th. I did have that. Okay, I remember when I assigned it that we have Memorial Day. So no class on Memorial Day. Hopefully you get a chance to do something fun, go barbecue, do whatever you do to celebrate for sure. And then we'll come back. So Project 1 on 6/7, and then we'll pick up Chapter 4. So I'll give you more time on the Chapter 3 quiz as well. We'll just, I don't know, pretend like that week is an entire week break or something, like it doesn't exist. We have that same problem with the 4th of July, it being observed on the Monday, so we don't have class, which is really unfortunate, because it means we have 1 week less. I was confused by that, but apparently that's the plan. Yep, so we'll talk about decision structures tonight, all of Chapter 3 material. Don't forget the textbook slides, if you like those sort of things, I've got out here. I just don't go through them. I don't like reading PowerPoint to you folks, essentially. But I have them all here if you want them to follow. And it's actually all the chapters. We don't get into all of them. But if you want them, we'll have them all here. Right? And then all of these code examples are out here as well. If you don't want to have to type it all yourself, you can just download it from here. And all the code I do, again, goes in this course repository. This is the GitHub repository. Oh, why did it open twice? That's funny. The GitHub repository. So all the code examples I do will show up here as well. So let me fire up NetBeans. NetBeans. Come on. Work with me. There we go. This will probably make it lag a minute. NetBeans is super slow for some reason. It's a little sad, but that's okay. We'll do all right. All right, awesome. Grab that up here. And then don't forget, we do have study group on Wednesday, 5 to 6. And we're going to have study group the week of Memorial Day, right, Tim? I don't think you're planning on taking that one off. because it's not actually like a week-long holiday. It's just the Mondays off. And then I've got fighting with D2L, which is really unfortunate, trying to get those bonus points in for you folks. Yep, so we'll have study group this Wednesday and then a week from Wednesday. So you can get a bonus point for the weekly quizzes each time you folks attend. So two bonus points for that week, I guess, for quiz 3. And I'll work on getting those added in. All right, so we have netbeans. Cool. Don't need that one. All right, so again, I'm going to do a Java with Ant project. Sorry about the Gradle stuff. It sort of can get fixed, but it's obnoxious, and then it's still error. So we're just going to go back to Java with Ant. This should be the easiest one for you. And wherever you put it, right, you want to put it inside of your repository folder that gets created. So I'm going to put mine in 1500, because that's my course repository folder. And we'll call this one Chapter 3. So control structures is the fancy term for this. It's all about controlling which code runs and trying to make our code smarter. So everything we've done so far, it just goes from the first line of main to the second line to the next line, the next line, the next line, on and on and on down. Right? And it just runs from top to bottom. And everything that we tell the computer to do, it does. Right? So we can say, hey, let me print, hello. Oops. And then maybe we use one of those scanner things. We say scanner keyboard equals a new scanner given system.in. Again, don't worry too much about all the details. This will make more sense once we get through a couple more chapters. So just type in the magic words and it works. And we add our import, thank you NetBeans, and then it's happy. And then if I want to get some input from the user, right? So maybe I have a int for favorite number, right? There's a setting you can go to, Quinn. I always say I'm going to do it later, and then I never do it later, so I just delete them by hand. It's somewhere in your tools and options or templates, I forget. It tells you where it is. Yeah, I think, was it templates? I forget. Might have been templates. Java templates, Java class. Oh, no, that's not it. I think that's in here. Java class. Let's see. Can I open an editor? Oh, that's ugly. No, don't mess with that. All right, so if we want their favorite number, right? Remember, if we do keyboard.nextLine, nope, next line. Next line will always give us a string result back. String is just a bunch of characters, so you can't save that as an integer. So we need to do some converting. And we should probably also tell them what to enter. So we'll say, hello, what is your favorite number? Okay? So they'll enter something with keyboard.nextLine, and what we want to do, we want to turn that into an integer. So it's integer.parseInt, given the keyboard next line. Okay, we can do it all in line, and then we can get their favorite numbers. We can print it back out. Right. Your favorite number is, and then we're going to append in here, favorite number, right? We're not adding. This is the appending here. So it's going to turn this into a string and stick them together. Right? If you put more than one string in a print line, it's just going to put them together. If you put a string and an integer, it's still just going to smush them together because it's smart enough to know you can't add a number to text. Right? Java says, hey, you've got text over here and a number over here. You probably don't want to add, right? You just want to concatenate. Just stick them together. And that's what we get. So we should be able to give it a run, and let's take a peek, just make sure it works. I'm a big fan of running early and often. Right? Every time you get a little bit of code done, run it. Make sure it works. Because if you write the whole thing first, and then you hit run, and something doesn't work, you're going to be really confused and not really know where it doesn't start working. So we'll say 42, and it should say your favorite number is 42. Look at that. It's smart. Thanks. That's our output. Yep. Okay. So we got our favorite number. Now, you want to see a fun trick? let's take a magic number equals favorite number times 9. So we'll multiply our number by 9. Let's do 10 to 99 here. Okay? And then we want to get the tens place. Actually, no, we want, what is it, the hundreds place? Hundreds place. Hundreds place. Is that right? Yeah, the hundreds place then will be our magic number divided by 100. And we want integer division. So in this case, integer division is good here. So integer division drops the decimal remainder. Remember, if you take an integer divided by an integer, so if we take the magic number and we divide it by 100 with integer division, we're going to get back just how many hundreds there are. If there's no hundreds, there's no hundreds. That's fine. It'll do the same thing. So now we'll have a tens place. Now this one, though, to get the tens place is a little bit harder, because what we want is to get rid of all of the hundreds first. So to get rid of the hundreds, we get magic number modulus 100 gives me the remainder. Right? So this is the remainder of how many we have left after we divide out the hundreds, and then we integer division by 10. And then the ones place is my magic number mod 10. Right? That's after you divide out all the tens, which will get you all the hundreds, it's all of them together. And then we can system out print line our hundreds place plus, I'm going to put some strings here to make sure it doesn't actually add, because if we said tens place plus strings, oops, that was too much, plus the ones place, right, we should get back out our number. So our favorite number times 9, let's see what we get here. Favorite number, if it's 42, 42 times 9, let's go check it, right? Open up the calculator, gives us a quick check. What is 42 times 9? 378. Looking good so far, right? Now here's a fun one here. So if we add those together, so this is the int sum of digits, is the hundreds place, plus the tens place, plus the ones place. Okay, we add them together. Then I need to get the sum tens place. So this is sum tens place, is the sum of the digits. And if I just want the tens place, right, I'm going to divide by 10 with integer division. How many tens are there? And then I'll have an int for sum ones place, is the sum of the digits, modulus 10. Okay? And then we're going to print the sum of the tens place plus the sum of the ones place. So, or no, the sum's tens place and the sum ones place. And this number here, let's see, I bet our magic math gives us 9. Let's take a peek, see if it works. All right, so favorite number for 42, 3 plus 7 plus 8 is 18. 110, 8 ones is a 9. We get a 9 out. Let's try it with another number. Someone shout out another favorite number between 10 and 99. Let's see if we can make this thing work. Actually, I think it works for 1 to 99. Is that right, Tim? 67. All right, 18. We got 18. 162. 1 plus 6 plus 2 is just 9. Perfect. All right, let's run it again. 67. 67. 603. 6 plus 3, just a 9. Perfect. Let's try it again with a 93. All right, let's try it. 93. 8 plus 3 plus 7. 11 plus 7, 18. 18. So 1 plus 9. We get a 9. I think it works with one-digit numbers too, right? Because then you just don't have a 100s and a tens place. So if you just do like 3, you get 27. 2 plus 7 is a 9. Look at that. Does it work with 3-digit numbers? We do like... Oh no, because I wasn't doing the thousands place. We can't do more than a... what's the biggest number we can get? Like 100, 111? Gives us 999? That one works too. 117, well, so we're losing the thousands place. So if we do bigger than that, I think it's going to fail, isn't it? Let's try it, 117. Did that work? Oh, because okay, so we're getting a 2-digit number here. So the number of hundreds in that case was there were 10 hundreds. Right, so 10 plus 5 plus 3 is 18. Look at that, it does work. That's magic, isn't it? No, no. This is just a silly example, just trying to go through some of this using variables, right? Declaring variables, doing arithmetic, right? And just spitting things back out. You have to memorize it if you want to be a math teacher. Yes. Okay. So again, this was all stuff we would have done in chapter 2, right? Using some operators, doing some arithmetic, adding stuff together, just having some fun here with magic numbers. 9s are really neat. I think that works with anything you multiply by 9, right? If you just keep adding up the digits, and then adding up the digits, you get smaller and smaller and smaller. I think it works like forever, I think. Although Java is going to have trouble with integers that get larger than 2 billion, so good luck coming up with really long numbers, right? We'll have to use something longer than an integer. No, just a quick review. Not a problem at all, Johanna. Yep, just having some fun. Okay. So all of this, again, we start at the first line, and we do the next line, and the next line, and the next line, and the next line. So notice I put a lot of white spaces places. Like I have a bunch of empty lines between things. I just think it makes it easier to see. Usually you'll typically kind of group things that are related. So maybe grouping these is all fine, because this is 3 operations for the hundreds, the tens, the ones. These ones were grouped together because it's tens and ones. Here's a print, here's another print. It's just however you want to put your code. Right? Remember, the white space doesn't matter. The white space is for people. Right? The code is for people. As long as Java can understand the syntax, it's happy. We make variable names to make people happy. Right? Java doesn't care if this is H. Right? We care because it's really hard to read if you don't give it good variable names. So good variable names are important. Okay? So how about we now ask somebody, enter a number, and we'll tell you if it is even or odd. Okay, so we need a number. So this is, I don't know, some number is integer.parseInt given keyboard.nextLine. Right? Get the next line from the keyboard, turn it into an integer, save it as some number. You kind of read right to left as we go. Remember, the stuff on the right happens first, in order of operations. It's inside of parentheses, so this happens first. We get the line, we hand it to integer parseInt, we assign it. Remember, this is not equals, this is assign. This is the assignment operator. Okay, gets put over here, and we're stored in as some number. Now, do you folks know any math to figure out whether or not something is even or odd? I know you didn't know you would be doing so much math in this class, right? How do you tell if a number is even or odd? If it's divisible by 2. Okay, sure. So how do we see what, yeah, if there's no decimal, if it's evenly divisible, what does that mean in terms of math that we can do? Because we can divide, but that's just going to give us another number. Yeah, no remainder. There you go, no remainder. So we can use the modulus operator here, right? So if we modulus by 2 and there is no remainder, the number's even, right? So and what we just said, we said it in English, we said if you can do this, then it's even. And in Java, we do the exact same thing. We say if, and then you give it a set of parentheses. And what happens inside the set of parentheses here is you need to tell give Java a statement that is true or false. Right? When you say if, you're going to do it if it's true, and you won't do it if it's false. Right? So we're going to say, hey, if some number modulus 2 is equal to 0. So now we use the double equal sign. This is the equals operator. Right? Double equals is equals because single equals is assignment operator. This trips people up all the time. Okay, but that's all right. You'll get used to it. And Java is nice enough to yell at you if you have a single one here. It says unexpected type, required variable, found value. That's not very helpful, right? And it's the hint here is not helpful either. That just means we did it wrong. So we need two equal signs. We're saying, hey, if when you modulus this by 2, you get 0, then it's true. So with an if statement, you give this, we call this an expression here. This is something that will turn into a true or false. We're going to ask Java to do something. Whatever it happens to be will give me a true or false result, right? Because it either equals 0 or it does not equal 0. So you get a Boolean. Remember we were talking about types? A Boolean is a single bit. It's a true or false, right? It's either on or it's off. That's your Boolean. So you need to give it something in here that is a Boolean expression or even just a Boolean. Right? If you could just give it true or false, or like have a variable like a Boolean, this is true. And you could give it this is true as well. Like you could say if this is true. Sure. This is fine too. So a Boolean or a Boolean expression. So if requires a Boolean or Boolean expression to check. And if it's true, everything inside this set of curly braces will run. So we're going to say your number is even. If it's not true, then it doesn't run. And what we can do is we can say else with a set of curly braces. If it's not true, the else runs. So we say if this is true, run the if. And we call this a block. This is like a block of code. This set of curly braces here defines this block of code. Else defines another block of code. So we can have as many things in here as we want, right? It doesn't matter. We can have anything in here we want. This entire block will run if this if is true. Okay? And with the else, then we'll say if it's not even, it must be odd. Okay, so this gives me control over my code, right? This is a control structure. We're saying if something's true, this line of code runs. If it's not true, or if it's false, right? Not true equals false, it's this one. This percent sign is the modulus operator, where it's doing the division and giving us the integer remainder. So when we divide some number by 2, it's whatever the remainder is. That's what the modulus operator does. Nope, else is not required. Yep, you can have an if without an else. And we'll get to some other examples in a minute, but I think this follows our odd number example better. So if it's true, you get this. If it's not true, you get this. Okay, so let's give it a try. Right, enter a number, sure. All right, enter another number. We'll tell you if it's even or odd. And we will tell you if it's even or odd. So how about we do 42 again? Your number is even. 42 is even. That is correct. Right, so it looks like it's working. Now let's also try it with an odd number. So anytime you write code, you want to test it and make sure it works. Right? Because just because we wrote it and we know what we thought it was supposed to do doesn't always mean it does what we think it's supposed to do. Oh, for sure. Yep, you don't always need an else. It's totally up to what we're trying to do. So in our case, you're either odd or even. That's it. Right? In an example Mr. Gaddis gets to in a minute, it's like if you look at the weather and it's raining, you bring an umbrella. There's no else. Right? It's just, if it's raining, bring the umbrella. There's nothing else that has to happen if it's not raining. Right? So it totally depends on what you're trying to do. So in our case, you're either even or odd. So we need this or this to happen, which is okay. Right? So we're going to test it now with an odd number and make sure we get this odd result here. So let's give it 43. Oh, we have to do 43 again, and number's odd. So looking good so far. Okay, so this is an if with an else. And so Mr. Gaddis will tell you, and it is technically true, that you don't need to have curly braces. It is not required. The problem with that is if you don't have them, it will only run the first line of code after the if it's true. And then everything else will happen no matter what. So it's really, really bad practice. I strongly discourage everyone from ever not using curly braces. You should just always have them. It's a good habit to be into. Nope, so this Boolean variable is just if you don't want to have an expression. So an expression is something that Java will say, hey, is this true or false when it's running? Because we don't know what some number is, right? Some number depends on what the user entered. So I don't know if it's going to be true or false before the program runs. If I give it Boolean, this is true, and it's true here, I know it's going to run. There's no expression happening. Right? Nothing's getting evaluated. The computer doesn't have to do any work. It just says, oh, it's true. Yeah, let's go. So an expression here means we need to do something. Right? It's doing some sort of operator. Okay? So we have lots of what we'll call relational operators. So equals, remember the double equal sign here, is a relational operator. How does this relate to the other? Is it equal to the other? You could have a not equals. So that's an exclamation mark equals, is a not equals. So it's the opposite of equal. If you don't equal, then it's true. So in this case, we would say if it does not equal 1, then you must be even. Because in our case, if I know if I'm modulus by 2, I'm either going to get a remainder of 0 or a remainder of 1. If it's not 1, you're even. I find this to be more confusing, right? I prefer the some number modulus 2 equals 0. But it's the same thing, right? You're saying you either equal 0 or you don't equal 1. In our case, we know it's only one or the other. So, and it's not always the case, right? We could say, hey, guess a number between 1 and 100, and you probably don't want to have to say, hey, does it equal 1, or does it equal 2, or does it equal 3, or does it equal 4, or does it equal 5? You would say, like, does it not equal this number? So it's just you use this depending on what we need to compare. That's a relational operator, okay? You could also say, if we wanted to have, we'll say if some number is greater than or equal to, so you can do greater than, or you can do greater than or equal to, either one's perfectly fine, 10, that's a 2-digit number. Right? So if it's greater than or equal to 10, it's a 2-digit number. Else, we'll just say, I don't know, it's not a 2-digit. No. So, you know, this is, they could have entered something even larger, right? They could have entered like 5,000 or 5 million. So maybe that's not true that it's a 2-digit number. So that's not good here. That's not going to work for us. Okay, but you can do greater than, you can do less than. We'll look at some of those in a minute here. Okay, but what happens is all of these expressions here have to give you back a true or false. Right? Is it greater than or less than? Or I'm sorry, is it greater than? That's either true or it's false. You get yes or no. Right? So we can use that in an if expression. Okay? Yes, and always use the curly braces. Interestingly, remember, because characters are stored as Unicode values, you can compare if one character is less than another. So I can say if like C is, or I don't know, E is less than R, do something. Right? Else E is not less than R. And what it does is it's actually comparing the numeric value. So letters earlier in the alphabet are less than. This is just sort of silly, but you can compare them. Okay? So you can compare numbers, you can compare characters. Strings don't work so well. We'll talk about that in a little bit, but strings don't work so well for some comparisons. This one here, we were just looking at both options here. So we could say it's either it's not 1, means it's even, or it is 0. Yeah, we could do either one. So I was just showing you, so the not equals operator and the equals operator. They both work in our case here, checking for even numbers. Yep. Yep, either one's fine. Cool. Okay, so now let's do a dumb thing, but it's okay. This is a fun illustration. We're going to check and see how big your number is. Okay? Right? And we can do this lots of different ways, but we'll have some fun with this. So always use curly braces. Always. Just always use them. Technically, you don't need them if you only have one line. And I'll just say that's terrible. Please just always use them. It never hurts to have curly braces. You folks probably don't remember, but if you're fans of Mac or Apple, they have this browser called Safari. And years ago now, probably, I don't even know how many years, maybe 10, 15 years ago? Oh, geez. It's been a little while. But they had a bug discovered that broke SSL encryption. Meaning when you go to a secure website and use HTTPS secure connections, it was vulnerable to a particular attack. The reason that happened is because one of the amazing developers there at Apple had an if statement and didn't use curly braces. And they wanted like 3 lines of code to run instead of just the first one. So what happened is the first one would not run if it wasn't true, but then the next 2 run all the time. Because without curly braces, only the first one is attached to the if. It's just a big no-no. So just always use the curly braces. You're being very explicit about what belongs inside my if. Okay? You just want to say, this should happen if this is true. Or this should happen if it's else. Okay? So let's do a silly example. So again, we want to see how big our number is. So we're going to say if the sum number is greater than or equal to 10, now what I want to do is I want to check again. I want to say if some number is greater than or equal to 100, I'm going to put an if inside of an if. This is called a nested if statement. This is perfectly fine. And again, let's just get silly here. Some number is greater than or equal to 1,000. Do another one, and if some number is greater than or equal to 10,000, oops, format that. Right, and on and on and on and on and on and on. So if some number is greater than or equal to 100,000, oh goodness. There we go, so 100,000, and we need to keep on going, right, because we need to find out how big this is here, right? So if some number is greater than or equal to 1,000,000, so you just always want the brackets. So if you get confused like I do with place values, remember in Java you can add an underscore in your numbers. I love this. So underscores are ignored. Now the problem is you can put them anywhere you want. Like nothing says you can't do this because it essentially ignores them. I definitely don't recommend that. Remember again, the code's for people. So if you want to add a digit separator, you can put an underscore in your number literals here. That's a great tip. Okay, so we'll go to then 10 million, and then we'll go to 100 million, and we'll go to 1 billion. Okay, and look at that. All the way down. Now, I don't know how well it's coming out on stream, but you can see if I click on a curly brace, it highlights the opening curly brace, right, for each one of these. And you also get this real thin gray line here that you can kind of visually follow up. Here. Okay, so now if it's greater than 1 billion, I can say your number is more, or what, at least is in the billions. Okay, if that's not true, this code doesn't run. Okay, so but I want this one, it must be true because I'm inside of this one. So if it's greater than 100 million, but it's not greater, so I'm going to have an else here, right? So if it's not greater than 1 billion, but it's inside the 100 million, let's say Our number is in the 100 millions. Okay? That ends that if. If we're at 10 million here, if we're 100 million, great. If not, then our else. Your number is in the 10 millions. Okay? So if you're greater than or equal to 10 million, if you're not greater than, you hit this else block here. So this is getting really gross. Yeah, when you open a curly brace, if you say if, you start an if statement, if true, and you hit curly brace, and you hit enter, it adds another one for you. NetBeans is really handy. Yep. So it adds matching curly braces for you. Okay. All right, so that is this one here. So if that one's not true, else. Nope. Shoot. All right, that's the else. This one here. Else. Your number is in the millions. You're running the curly braces all within each other. Yep, so if it's greater than or equal to 10, this block of code, everything from this curly brace down to this curly brace is going to run. The next thing it does is it checks if this is true and runs that block. If that's true, runs this block. If that's true, runs this block. These are called nested if statements, and this is ugly and horrible looking, and that's okay. Right, so if it's not greater than 10 million, but it is greater than 100 or 1 million here, we get this else block. Right, this is the else attached with this if up here, 10 million. We're going to add more here then, so this is in the 100,000s, 100,000s. Do that little format. Okay, and then that's the 100,000s, right? If we're not the 100,000s, then we're in the 10,000s, 10,000s. Okay, we're getting there. 10,000s, and then we're in the thousands, thousands, and then we're in the hundreds. If it's not in the hundreds, it's in the tens. And if it's not in the tens, right, if it's not greater than or equal to 10, oh my goodness. Yeah, the lines show you which one belongs to which. Else is in the ones. Okay, so all of that, oh my goodness, this else, right, is attached all the way up to this if up here. Right, that if curly brace ends right here, and then I say else. Yep, no, questions are good for sure. This is a really ugly looking example, but Java is okay with this. Java doesn't care, right? And this should do what we're asking it to do. Right, so let's try a couple numbers and see what we get. So this curly brace, right, is the main here, all the way up at the top. Public static void main string args. Everything goes between this curly brace. And notice it even kind of pops it up. When I click on it, it's showing me, hey, up at line 7. It's pretty cool. So let's try it. Let's see if we can get our result back out. Just some number, sure. Okay, how about a big of it? No, even this is some number here. So let's go like 2 billion. That's 2,000, 2 million, 2 billion. Is that it? Billions. Right, our number is in the billions. Hooray! We found it. Let's try it again. Let's give it a smaller number. 42. How about like 777? Numbers in the hundreds. Looking okay so far. Again, you probably should try every single one of these options and make sure that you're getting the result that you expect. Because if you haven't tried to make sure it works, then you have no expectation that it does what we asked it to do. People make mistakes in code all the time. People who've been doing it for years and years and years and years make mistakes all the time. Okay, I will surely demonstrate mistakes to you, and I will pretend that it was on purpose, but it just happens. Right? People make mistakes. So anytime you write code, you want to test and make sure it's doing what you think it should be doing. So this is nested ifs. This is ugly. Okay, and you could just have one, you could have two, I mean, as many as you want. And again, if your code is kind of scrolling off to the right, and you have to scroll to the right to see it, you've done a bad thing. My font's zoomed in a little bit, or it's kind of a large font, so it would probably be fine, but it's considered bad form to make people scroll to see your code. Right? It should fit on a screen, right? Because code's for people. That's kind of the rule of thumb. Okay, so that is one big long ugly if else if or if nested ifs here. Okay. Now instead of this, I'm going to show you one that's going to look even better. So we can clean this up a little bit here. So instead of that, what we can do is we can have something that it gives us more than one chance to match. So right now with an if or an else, right, it's either this or that. It's either this case or this case, right? You get A or you get B. There's no other choices here. But what we can do is we can add more checks here. And what that looks like, we call that a chain of if, else if. So we could say if some number is greater than 1 billion, I keep on to hit shift on that. So if the number is greater than that, right, we'll say your number is in the billions. And then if it's not, I would say else here. And then right away I do another if. If some number is greater than 100 million. Your number is in the 100 millions. Okay, and then again, else if. So if that's not true, we go to the else. If this is true, do this. So in the 10 millions, else if, oops, let me back it up one. Again, it's just formatting here. In the millions. And then I'm just going to grab a bunch of them here, right? Because I like copy pasting here. So then we'll just take out a set here. So that's 100,000s, that's 10,000s, that's thousands. Thousands, 10,000s, thousands. Okay. Grab a couple more, and let's take out another block. Hundreds, tens, and really we don't even need there's no if here for ones. Okay. Hundreds, tens, and ones here then is the last else. So what we get here is we're making a chain of if, else if, else if, else if, else if, else if, else if, right? It's the exact same thing as this, essentially. But it's not nested, it's a chain. So what we get here is one and only one of these will run. They are mutually exclusive because they're in a chain. Right? The first time something runs, right? If this one is true, this code runs, this else does not. So if this else doesn't run, none of this runs. We stop. Right? So the first time you hit an if, that block of code runs and nothing else does. So this way we can do better checking. Right? We start up here, okay, we're greater than a billion, we're in the billions. If not, are we greater than 100 million? If not, are we greater than 10 million? If not, are we greater than 1 million? If not, are we greater than 100,000? On and on and on and on and on. You don't have to have an ending else. You call this the default case. Right? If it doesn't match any of the ifs, we get our else. That is optional. Again, it just sort of depends on what you're doing. So in our example, we know you must be the ones. And this is technically wrong if you give them a negative number. But again, we'll pretend people won't give us negative numbers. We can just pretend those don't exist. Right? I mean, most people, unless you're an annoying math person, and when they ask you to guess a number or give them a number, they give you a positive integer. Right? Most people don't give you decimals. Most people don't give you fractions. Just don't ask math teachers because they're weird people. That's fair to say, right? Okay. So it does the exact same thing as this. That is not nested, but it's a chain here. That's all we did here. Okay. Let's give it a try. How about 987654? The 100,000s, right? Yep. 987,654. 100,000s. We get 100,000s both times. Looking good so far. So that's an if, else if, else if. A hat. You got it. I've got my favorite hat here. pretty sure I got this on my honeymoon when we went to Disney. I think it's that old. It was actually my first trip to Disney, and it was fantastic, actually, to go as an adult. Such a fun place. I've taken the kids a couple times. They enjoy it, too. So, not quite as relaxing, though, when you have the kids with you, but that's okay. They have a lot of fun, and it is magical. Yeah. My wife had gone, I think, twice as a kid, and really liked it. And it was fun. They had that, like, Disney dining plan you could get, so essentially the food was kind of all included. With the upfront cost of everything. It was fun. How old was I? Wow. Making me do math. I was 20. Yep, I got married a little young. But that's how I've got 6 kids now that I'm 34. Tech, switch statements. You must have been reading ahead. Tech, I hate switch statements. I think they're dumb. Some people love them. Sure, there's nothing wrong with them, but it doesn't work in a case like this because this is not, there's no matching that you have to do with the switch, right? So we like can't replace this with the switch statement. Yep, and we'll get to switches in just a little bit here. Yep, that's a good question though. Okay, so we've looked at these relational operators here. Oops, these all should have been equals. Less, greater than or equals, right? Because if you equal 1,000, you're in the thousands. Right? I was making a mistake there. Did I do it right up here? Okay, I did it right up here. All right, good. I feel better. Okay. Okay. Awesome. Well, thanks for coming on by. Java Virtual Machine. I love your username. Good to see you. Thanks for coming along. You can exclam GitHub there if you're curious, and I might as well commit. It's good. Commit early and often. Commits are free. Commits are free, in fact. All right, so make it 1500 for the summer, and Git's going to say, "Hey, I see a bunch of new files." Right? All the project files are fine. Just leave them alone. It's all well and good. We care. Do you have your .java file here? That's the one I'm going to look at for evaluating your stuff. Okay. So here's if, else, nested if else chains. If else if chains. Okay. Did they get laggy? What's my computer doing? That was warm. I forgot I moved my fan. It's okay. We don't need zoom right now. Trying to think what else I can kill. Yeah, IntelliJ is fine. We've started using NetBeans at the campus because that's what Dr. Baugh did, and he's a lot smarter than I am, so I said, sure, I'll use NetBeans too. Yep, so I'm a new full-time faculty member as of the fall semester. This is my 3rd semester as a full-time faculty. Here I've been adjuncting for quite a while, and I've just used the tools that they were using, so just kept that same format. Yeah, Kotlin's fine. No, we're sticking with Java. You can do Kotlin if you want to do the Android class. All right, so far our expressions here, then this is using a relational operator. Okay, we have another choice. We can do this a 3rd way, believe it or not. You know, when it comes to coding, there's pretty much always so many different ways to do things. And it's okay. It's all up to you. So I'm going to do this without an else here. I'm going to show you some magic here. So to do it, we need to add a new kind of operator. Right, we're going to add another operator. So we're going to say if my sum number is greater than or equal to 1 billion. So this one is the same one here. Excuse me. Your number is in the billions. Okay? And now without an else. Yep, you'll always have to have it. Otherwise, Java gets really confused. So when you go to run your Java program, Java looks for this main place to start. So you can only run something that has main, essentially. Yeah, that'll always be true for us. right? So the only time you can run Java code is when it runs the main method. So if you don't have public static void main string args, Java doesn't know how to run it because it doesn't know where to start. Yep. How are class templates stored in memory? Like when it loads a class up? Yeah. Yeah, I mean, switch statements are fine. We haven't got to them just yet. We'll get to them a little bit later in the chapter. But they work. Yeah, main is the entry point tag. So that's where it knows to start. So without an else here. So if this is true, this runs. Now, we're going to do something else. So now we're going to say if some number is less than a billion, and, so I want to say, hey, if this is true and this is true, right? And in Java, that is the ampersand operator. That's the and operator here. If it's this and some number is greater than or equal to 100 million. Okay, so if both things are true, the whole thing is true. I don't actually know Java Virtual Machine where annotations are. I'm assuming in the compiler. Somewhere in the Java compiler, my guess. So if this is true and this is true, then the whole thing is true. So anding here is a logical operator. It takes a true and a false and a false and will give you a single result. Right? And with anding, it's only true if they're both true. Okay? There's also an or operator you can use. That's pipe. You can, that's the shift backslash is the pipe. That's the or operator. And I always like to tell the story of McDonald's. This always helps me remember it. So when I go to McDonald's and they say, hey, welcome to McDonald's, would you like a burger and fries? Right? If they say burger and fries, I say, no, that's gross. Your fries are disgusting. I don't want your fries. So my answer is no, because I don't want a burger and fries. If they say, hey, welcome to McDonald's, do you want a burger or fries? I say, yes, please give me one of those juicy double quarter pounder with cheese burgers. That's actually a decent burger, and it's supposed to be cooked fresh. Now, if you've worked at McDonald's and that's not the case as they advertise, please don't ruin it for me. Don't tell me. I don't want to know, right? I want to assume that it's cooked fresh like they said, and it's juicy and delicious. Double quarter pounder with cheese, the best burger. Okay, so if they say, do you want a burger or fries? If either one of those is true, you say yes, right? So the same thing works with our operators here. So and, they both have to be true. If they say burger and fries, you say, no, your fries are nasty, gross, no. Answer is no, because one or both of those things is false. Okay, so there's actually a little table here. You have true and true is equal to true. You have, I'll probably just do this in a comment here. You have true and false is false. You have false and true is false. And you have false and false is false. So only it's true when you're anding. So this is logical and. So that's the ampersand. Only if they both are true is it true. And then with the logical or, you get true or true. The pipe is true. Here, I'm just going to copy these. That'll be faster. You get true or false is true, because if one or the other is true, the whole thing is true. So false or true, the whole thing is true. And false or false, now you finally get a false, right? If you or, they both have to be false for the answer to be false. If any one or both of them are true, the whole thing's true with ors. So just remember the burger and fries, right? I mean, go get some decent fries like Wendy's or Arby's. The curly fries are fantastic. Wendy's does some really good fries. They're like actual slices of potato, not like rehydrated potato mush that I don't know. The fries are terrible. And they add milk to them, which is the weirdest thing. So if you're dairy intolerant, you can't have McDonald's fries because for some reason there's milk in their recipe, which does not belong in French fries. Yeah, you can have more than one, of course. And logical operators have an order of precedence. And that's a fun one here. So The ands and ors happen with ands happening first and then ors, and that's confusing. So anytime you mix and match, I recommend you use parentheses to force order of operations. Because you could say, hey, is this and this, or we could say, or, I don't know, some number, I don't know, equal to 50. I don't know. We'll just, okay, let's pick a number. So something in the 100 millions, 500 million. Right? So this will and first, and then this will or. But if you had the or over here, and you had the and over here, this is going to and first, and then it will or with this one. So just be careful, right? Again, if you're going to mix and if you're going to have multiples, I always recommend parentheses. Right? Never hurts to add parentheses. No, I've never done much with Spring. Yeah, parentheses are your hero. You know, force that order of operations. Okay, right, we should actually probably move this up. So let's put this up here. Okay, so we say if it's less than a billion and it's greater than or equal to 100,000, we can say your number is in the 100,000s. Yeah, order of precedence is hard. Order of precedence is hard. Okay, we'll do this again. So now we're going to say, hey, if you are less than 100 million and you are greater than 10 million. Oh, that's millions, right? In the 10 millions, right? Greater than or equal to 10 million, but less than 100 million. And now we'll go to less than 10 million, but greater than 1 million. You're in the millions. Okay, if you are less than 1 million, but greater than 100,000, you're in the 100,000s. Thousands. Yep. All right, if you are less than 100,000, but greater than 10,000, you're in the 10,000s. If you are less than 10,000, but greater than 1,000, you're in the thousands. If you are less than 1,000, but greater than 100, so 100, you're in the hundreds. Hundreds, there we go. If you are less than 100, but greater than 10, you're in the tens. And my last one here, then I want to say if you're less than 10, but greater than or equal to 1. So you can't have a default case here because there are no else's here, right? So you have to be careful, right? Can't have a default. There are no else's, else blocks, right? So everything needs to be an if this is true, it matches here. Okay, so we can write this exact same thing without any if statements. I'm sorry, without any else statements. It's a whole bunch of ifs. So these ones are not mutually exclusive. When you have a chain here, this chain of if, else if, are mutually exclusive. Mutually exclusive. One and only one will run. Guaranteed because they're chained together. Yeah, Silver, they're all on GitHub. If you do exclam GitHub there in chat, or if you check out D2L, it should have it there for you. So these are not mutually exclusive here. Not mutually exclusive. Exclusive. So be careful with the or what the if blocks. So we know because we wrote this here, I know only one of these will be true unless I have a typo, right? And it's really easy to typo this sort of thing, right? Again, that's why these number separators are super helpful, because it should jump out pretty quick if something didn't line up here. But if you screw something up, more than one of these could run, right? If it's true, that block runs. If this one's true, that block runs. Now, I know that some number can't fit into more than one of these blocks because of how we wrote our if statements. But that's just us writing our if statements, because we are in charge of the if statements here. With the chain here, the first one that hits, we're done. That one runs, nothing else even gets looked at. So this is technically faster behind the scenes, because Java only needs to find the first match and then stop. Where with this one, even if it's greater than a billion, it still checks the rest. Hey, are you less than this? Or are you less than this? Are you less than this? Are you less than this? So Java has to do more work every time if we use just a bunch of ifs. So I don't recommend this approach, but I want to show you using these set of tools that we're learning, right? Using our logical operators like ands and ors, we can get the same effect as we did up here with our chain or with our nested ifs, right? So my definite preferred method here is always a chain of statements if possible. And again, it sort of depends on what problem we're solving, right? There's not always going to be just one way to do something. It depends on the problem we're solving. So Mr. Gaddis likes to look at that weather example. Hey, if it's less than 32, you should wear your winter coat, right? If it's less than 50, you bring your light jacket. Otherwise, we're in Michigan, we just wear our t-shirt outside because it's over 50. Hey, Blowfish, how are you today? Right? So just depending on what your cases are here, right? We could do that, right? It's a mirror of a university. It is a university course, Java. Type exclam course there if you want some more information. Yep. So again, it just depends on your case here. So if we ask, hey, what's the weather? What's the temperature? Temperature outside. Outside. And then we get that result. So in temperature is integer.parseInt. Again, almost no one's going to give you a decimal when you ask them what the temperature is. Like, no one's going to say it's 74.2. Exclam course, exclamation mark first. Yep. So we can check. So you can say if the temperature is less than 32, and again, this is Fahrenheit. Fahrenheit equals sad. But that's okay. We all know Fahrenheit temperatures. We'll say, bring your winter coat. Else if the temperature is less than, I don't know, we'll say like 50 maybe. We'll say, bring your jacket. Else, you're fine in a t-shirt. Right? This is our Michigan weather. Did that not work, Tick? Of course. Oh no, class. I'm sorry. I don't even know my own commands here. Exclam class. There we go. Oh, thank you so much for checking my posture there, Vita. Taking care of my back. This sitting all day long will hurt you. Yeah, exclam class. Okay, not course. I forget. I should add another. I should add that. Where is it here? Where is it here? Nightbot. I think we can add that as an alias. Might as well. So we'll say this is exclam course is an alias of class. I think that works. Now can we do course? Yes. Okay, cool. All right. Look at that. I can work Nightbot. I know you're all impressed. Yeah, okay. The bar is not that high. I'm sorry. Right, so again, just depending on what we're doing, right, this is a chain because we want them to be mutually exclusive. Only one of these things should happen, whether or not you bring the winter coat, you bring your jacket, or you're fine in the t-shirt, right? But then maybe we also check, hey, if it's raining or not. Right? We could say, hey, if it's raining, yes or no, then we should do something. Right? We've got lots of options for how we're doing this here. Before we get to strings, though, and like, hey, if I ask what the weather's like and you say rain or snow or that sort of thing, why don't we take a break? It's a little after 7. I've been talking for a while. You folks are doing awesome. We are cruising here. We're about halfway through chapter 3. Okay? It's okay if it's a little fuzzy. Practice is going to make it better. So definitely with this chapter, do some of the practices in the book. Mr. Gaddis has some great practice examples for you. We'll start using this stuff with our next project, project number 2. Okay? So read through it, do the practices, go to study group, talk about it. Because we've got to get this down and understand how we can do if and else to make sure the right code runs. Okay, so we'll take a quick break. We'll put some music back on, and we'll come back in about 10 minutes or so. So how about 7:18? That's 10 minutes, and we'll be back in a minute. All right, and again, sorry in advance for the Spotify ads.
trust to change, even if I want to realign. 'Cause I've been sitting here, same old ways, taking off without the same mistake. Darling, where you going? Won't be as simple for you. Time won't change anything if I don't know how to breathe. The current that pushed against the tide. Maybe once, maybe twice. Turned around to save the time. Now I know how to leave the side. If I saw another day, only to scream into the night. Nothing ever tries to change, even if I want to realign. 'Cause I've been sitting here, same old ways, taking off without the same mistake. Can I leave it all behind? Follow all the leading signs. When the dark is growing and the light is closing in, tell me where you're going. Won't be a simple voyage.
The journey to a COVID-19 vaccine began decades ago with research on earlier coronaviruses. Scientists built on that with months more of research and development, worldwide cooperation, and clinical trials on tens of thousands of diverse volunteers. Finally, they arrived at a safe, effective vaccine. The next step on the journey is yours. Discover the facts at michigan.gov/COVID vaccine. A message from the Michigan Department of Health and Human Services.
At Kroger, everything we sell is guaranteed fresher than fresh because our associates constantly check to make sure everything is at the peak of freshness. That means peeking at the peaches, spying on the steaks, and delving deep into the dairy department. So everything we sell is guaranteed fresh, or we'll make it right. Kroger, fresh for everyone.
Get more ways to save at the Buy 5 or More Save $1 each sale. Just buy 5 or more participating items and save $1 each with card. Kroger, fresh for everyone.
The e-tron fleet of all-electric vehicles from Audi is ushering in a new era in mobility. Engineered to deliver the exhilarating performance you expect from Audi with an eye towards a more sustainable future. Experience e-tron at your local Audi dealer today.
my mind. Succeeded with hope and you were sure I couldn't agree that we were meant to be, but our love is what they talk about in movies. Our love is what they talk about, what they talk about. Yeah, we were wild and free, and you know everything about me. So wild and free, and you know everything about me. 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 Save me from myself. I really need your help. I'm going under. Save me from myself. All I really ever wonder is if I really going under. Yeah, we were wild and free, and you know everything about me. So wild and free, and you know everything about me. 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 What the trouble with love is. What the trouble with love is. What the trouble with love is. Trouble with
Hey folks, welcome on back. Alrighty. That'll do. We'll come back to that one later, maybe. Alright. Hey, Zero. Hey, no problem. You can always catch the VOD. Alright. So we've looked at... This is all using numeric values here, right? Technically, you can use characters as well, because they're also numeric values, but again, that's just kind of funny. So comparing strings is the tricky part. And what happens is the equals operator here does not work. We can't use that. We can say, hey, what's the weather? What's the weather like? And we might, and you know, anytime you prompt your user, you should probably like give them some suggestions of what you're looking for. You might say like rain, snow, sun, something like that, right? Like tell us one of these options here. And then I'll have a string for weather. And that was just keyboard.next line, right? There's no conversion here. So whatever they type in, we're good. We got weather. So I can check. I can say, hey, if weather, now I can't say equals rain, right? This is no good. Don't use for strings, okay? Right, and then we might say else if the weather is equal to snow, do something else, right? So if it's rain, then maybe we'll say bring an umbrella. And umbrella, if it's snow, we'll say bring your scarf. I don't know. Sure, why not? Or gloves, maybe. Bring your gloves. How about gloves? Gloves are always handy. And otherwise, we'll tell them it's a nice day. Sure. All right, some numbers, some other numbers. What's the temperature outside? 10. Bring a winter coat. All right, we'll say rain. And we get, it's a nice day. Oh, well, that's not what should have happened. So strings and the double equal sign, it doesn't work. It doesn't work. That's a big sad there. Okay. So what we do instead here is, now strings have a really cool way to compare. You say dot equals, and then you can say equals or equals ignore case. And I'm a big fan of ignoring case, especially when we're dealing with the user's input. Because I don't know if they typed in a capital R, I don't know if they typed it in all caps, I don't know if they typed it in all lowercase, right? I want to equals ignore case rain here. And we do that every time. So we say equals ignore case, and you give it inside of the parentheses what we want to compare with. So when using strings, use equal ignore case or just equals, whichever you need. Right? So if you do care about case, uppercase versus lowercase, then don't use ignore case. If you don't care about the casing, then you should probably always use equals ignore case. It's rare that people care about the case, uppercase or lowercase, right? So the problem is, remember, because strings are not a primitive type, remember, in Java, and strings are immutable. Remember, that means they can't change. You actually make a new string in memory. So what the equals operator does for anything that is an object, right? Our ints here are primitives. They're not objects, they're primitives, right? So anything integer, anything double, anything float, anything bit or Boolean, right? Those are all primitive types. Anything else is an object, and objects, when you compare them here, compare, are you the same location in memory? Because remember, what Java says is, hey, go out and find me someplace in memory to store this big string, and it gets as much space as it needs based on how big the string is. So what the string variable actually stores is the memory address of where it's pointing. That's a fun story. So if we look at the whiteboard here, take a peek. Let's clear this one out. Right, so if we say like int number equals 42, right? If we tell that to Java, the Java virtual machine goes out and asks the operating system for place to store an integer. So it gets 4 bytes, right, of memory somewhere, and we'll say like x372f. I don't know. Remember, memory addresses are in hexadecimal for reasons. And at the memory address, it puts in the right bits for 42, which is a 2, not a 4, an 8, not a 16, and a 32, not a 64, not a 128. Right, and a bunch of other zeros. So 00101010 is 42. This is what's stored at this location here, because that's an integer, that's a primitive type. So number is this memory address, and we put the value there. When you say string, like name, Java says, and we'll assign this here to Eric. So Java says, hey, okay, name, you are, what you point to here is where I'm going to go store Eric somewhere out of memory, like x39ba, I get Eric. Remember, which is actually the Unicode value of E, which I forget what that is, Unicode value of R, Unicode value of I, Unicode value of C. Stores that. And what name stores is 39ba. So name, when you go and ask Java, hey, what's my string? The variable for string says, oh, go look here in memory, that's where your string is. If you go and change name, then later we say name equals Charneski. Can't even write my own last name here, but that's okay. Java says, oh, okay, let me go get a new location in memory. It can't change here because strings are immutable. You can't change the string that's there. And the reason is Charneski is bigger than Eric. It's more letters. It's going to take up more space. And Java can't guarantee that there's room at 39ba for a bigger string. right? There might be something that comes after it already. It's got enough space to fit this and only this. So it needs to get a new location. Maybe we'll say like 42F9. I don't know, why not? And that gets Chernesky. Charnesky. I can't even, that's fine, close enough, right? That is stored, remember the Unicode values, and then name now points to, it stores x42f9, which is here. So name no longer has this value, it now has this value. So strings are immutable, they can't change. So when you say, does this string equal this string? So does name equal Eric? It says, well, does 42f9 equal, quote, Eric? Nope. Big fat no. It does not. Okay, so we have to use equal ignore case, which goes and gets the value back out to compare it. Right, so let's see. This is more logical ands, ors, and strings. Ands, ors, and string. Okay, that's okay. Too many ands there, but that's okay. I'll commit and push. So we got that example. Okay. So now here's a fun one. Now, if I want, right, so this is like bring an umbrella, bring your gloves. How about we say bring your sunscreen? Sunscreen. Okay. Now, maybe you're thinking to yourself, hey, we're saying the exact same thing. Bring, how about your umbrella, bring your gloves, bring your whatever. It's the exact same sentence, and the only thing that's changing is this word here. So wouldn't it be nice if we said instead, we had, say, this here, and we don't do any of this. We cut this out, and we say, hey, string item equals umbrella. Nope, semicolon's on the wrong side. String item is gloves, and string item is sunscreen. And we say bring your buttercup. Yeah. Got it? Okay. Have fun. And we'll say bring your, right? And then we'll concatenate in there item. It's on the table. And now Java's confused. It says it doesn't know what an item is. Cannot find symbol, variable item. Location, class chapter 3. So it's looking everywhere in class chapter 3 and it has no idea what item is. What happened is when you declare a variable inside a set of curly braces here, we said here's a string called item, it only exists inside that set of curly braces. Exists inside the curly braces. It was declared in. Okay, so when you declare something, it only exists there. So we can't do that. It doesn't know what an item is. So what we have to do instead, we need to declare it outside the curly braces. We can say, hey, I want a string called item. Then I just say item equals. And now it's happy because we're not declaring it inside the curly braces. We're assigning it inside the curly braces, but it's getting declared outside. So item is declared inside the same curly braces as we're trying to use it here. That's called scope. So the curly braces you're declared in determine your scope. So they come into scope where they're declared, right? Just like you also can't use a variable before you declare it. So like up above here when we ask for some number. Before we ask for some number, I can't print some number. Because can't find symbol. You haven't declared it yet. You can only use it after you've declared it, after it has come into scope. Okay? So in this case now, right, we can say, here's an item, here's an item, here's an item. Can we not use curly braces for each if, but to only use one for all ifs? So like each block here needs its own set of curly braces to know what belongs to the if or the else. So this if gets this set of curly braces. This else gets this set of curly braces. This if gets this set of curly braces. You should just always use curly braces anytime you have an if or an else. Always use them. Really good practice. Yep. So now we can run. And now we should be able to say rain and we should get umbrella. So numbers, rain. And now we get bring your umbrella, bring your umbrella. Oh, it's a nice day. Remember, that was our one that was broken here. This one didn't work. Oh no, this one up here doesn't work. My phone? Oh, one of the kids was calling on Echo Dot. That's fun. That is fun. Okay. So when we do strings, right, we use equal, ignore case, or just equals. If, else if makes this chain of mutually exclusive, one and only one of these will run. If I have an else, that is the default. If it doesn't match this one, and it doesn't match this one, I get sunscreen. Which, if I said cloudy, might not be the case. But again, we're just saying, hey, sure, I'm assuming you entered rain, snow, or sun. Maybe sunny, I don't know, sun is silly, but that's okay. Okay, now, there are some people who are a fan of writing less lines of code. And sure, that's fine. That is okay. So turns out there's a shortcut for them because, all good developers are lazy and we don't like doing more work than we need to. So we always look for shortcuts for things. So let's see here. Let's say it's out. Enter how much money you have for lunch. Right, and then let's do this as a double, because maybe they'll tell me like 350. So we'll say double lunch money equals, and this is then double dot parse double, given keyboard.next line. And we'll say if lunch money is greater than, how about, like $5? If it's greater than $5, greater than or equal to $5, you have enough, here, let's say a string for lunch choice, right? And then we'll say lunch choice this equals, so if we have more than $5, we could probably make it to Burger King. Else, right, we have less than $5. I'm sorry, this should be right there. If we have less than $5, our lunch choice is probably ramen noodles. Right, and then let's print out lunch choice. We'll say, lunch today is lunch choice. Okay, so if we have more than $5, $5 or more dollars, we can go get Burger King. Otherwise, we're eating ramen noodles again. Okay, let's see if that works. Right, always test your code. So again, I'm declaring it outside of them, and then I have inside, I'm assigning the value, and then I'm printing it out here. And the whole idea is I don't want to have to type system.out to print line today's lunch today is more than once. I want to do it one time if this is the only thing that's changing. I just want to be lazy. 10, 10, 10, 10, 10, rain, yep, and $10 for lunch. So Burger King. Awesome. So again, this here is 1, 2, 3, 4, 5, 6 lines if you count curly braces, but 6 lines of code. Now, developers say, that's too much, I'm lazy, I don't want to write that much code. So they say, I'm going to use the ternary or conditional operator. So ternary means there's 3 things, right? Three things, right? 1, 2, 3. So we're going to assign something if it's true or if it's false. It's crazy. So we'll say string, this is, other lunch choice is equal to, and then I give it a Boolean expression. So I'll say lunch money, I'll say, how about less than 5 in this case? And then I give it a question mark. And this is why I hate ternary expressions, because I always have to go look them up, because I can never remember how they work. So the question mark is if it's true. So if it's less than $5, it's ramen noodles. Ramen noodles. And then a colon for the else. If it's not true, else, here the false case. How about, okay, so instead of Burger King, how about we do Wendy's? Wendy's. This here replaces this. We should do Burger King so it matches, right? We'll make a match. Burger King. And ramen noodles should be capitalized because I capitalize things weirdly. And then we can print out other lunch choice. This is a ternary or conditional operator, ternary expression, or conditional operator. So you give it the expression here, this is a true-false, question mark if it's true, colon if it's false. I hate these, I'll never write them again. Honestly, they just confuse me, right? And I think this is just as easy, and I don't mind writing it out. But sure, you can write this if you want. A fun fact, I think I mentioned a while ago how I fail people for cheating, and it's a big pet peeve of mine. I had a question on an exam, which was open book, open notes, right? I get paid a lot of money as a developer not to memorize things. No one's ever said, do this without looking things up, because that's stupid, right? So I don't expect you to either. But they all had a conditional operator like this in their solution. 7 people did. Now, we had talked about it once, just like we did now, and I said, I hate them, I'm never going to use them again. They've never used them before. So it looked really funny to me that they would all of a sudden use this conditional operator that we've never used in class ever. I talked about one time, like 10 weeks before the exam, and I'd never seen them use it in their code before. So I went and I Googled that line of code, and they took the entire block of code from some website, probably Chegg, because Chegg is the worst. I hope they go out of business and get sued. They are terrible people. They just copy-pasted an answer from Chegg, and they did not cite their source. So 7 people failed the final exam. No, failed the entire class, right? Because they cheated, they plagiarized, they took someone else's answer, presented it as their own work without citing it. It's plagiarism, right? They plagiarized on the final exam, failed the class, and they had to retake it. And that class was a prerequisite for the next class in the program as well. So then they had trouble getting into the next class, and it threw off their whole schedule because they couldn't take the next class because they didn't end up passing the previous class. It was a big mess, right? Because they used a ternary that they copy-pasted online. Because no one uses these, right? These are confusing. No one who, like, in the intro to programming class uses this ever. It's confusing, right? But you're going to see this in code because developers are lazy and they're like, oh, hey, 1 line of code is probably better than 6. Sure? I don't know. I much prefer this myself. So that's my long story about that. Okay, that's the conditional operator or the ternary. Okay, now switches. You might have saw some people in chat talking about a switch. A switch is a special case which can essentially do a chain of if, else, if, else, if, else, ifs. I don't like switches for a reason I'll explain in just a minute. I think they're obnoxious, but that's okay. We can do the same thing here with a switch. So, oops, that's too many. This one here. Okay, so I'm going to have a string for more, I don't know, another item, I guess? Sure, why not? And then I'm going to say switch, and then in parentheses, you say, what are we switching on? What are we going to compare this? So I'm going to switch on the weather. And then use a set of curly braces. Inside of here now, instead of an if, we say case. And you say case rain, colon, and more stuff. So if the weather matches the case of rain, then we will say item or another item equals umbrella. Then what you have to do is you have to add a break keyword. Break tells the switch to stop running. If you don't add the break, it doesn't know to stop running, and it's stupid. Another reason I hate switches. So case rain, how about case snow? We'll say another item equals, what do we say, gloves? Break? No, break. And then if you want a default, it's default here. And you say another item equals sunscreen. Now, after the default case, you don't need a break because the switch is done. Right? No break needed. Switch is already done. Okay? Now, the problem here is it does not switch case insensitive. So the trick for that then is you take weather and you say dot to lowercase. Yeah, switch using ignore case equals ignore case. So you take what you're switching to lowercase and then you compare it with all lower cases. Sure, that's an option. You can do that. Okay. The other option you can do, and I don't recommend it, is you can have more than one case, and you can say case rain like that, and it will match either one. So this is why the break is technically important, because the first time it matches a case, it then runs until it hits break. You don't use curly braces. It's really awkward and confusing, and I hate switches. I'm not a fan here. And then you can't do things like have a range. You can't have a switch that says, hey, is it between 100 and 10? unless you want to say case 10, case 11, case 12, case 13, case 14, case 15, case 16, case 17, which is terrible, right? We should recognize that's a bad idea. Some people love switches, and that's fine. But so every switch can be replaced with a chain of if-else-ifs, but not every chain of if-else-ifs can be replaced with a switch. Right? In this case, sure, because we can match on, does the string match? That's okay. In this case, temperatures, we can't do that. Less than 32 is not a case. We can't say case less than 32. So you can't replace this one with a switch. You can't replace this one with a switch. So for some cases, they're great, but most of the time, I'm not a fan of switches. All right, so let's save that. We'll commit that. Let's see, what do we have here? I formatted. Oops. Okay, sure. So here's string equal lowercase and switch. Oh, and the ternary. I forgot the ternary. Sorry. You'll forgive me, right? No, it's got to sync again. There it goes. Okay, so the last thing in the chapter here, you folks are doing great here, is prettily formatted printing, or formatting, essentially, formatting of strings. And there's two ways to do it. The first one is printf. I don't recommend printf. Okay, so you can read it, you can see how it works. It's going to work almost the same way that I'm going to show you is the better way. Okay, so essentially, let's skip printf because we don't need it. Okay, we're going to skip printf. You can read it. Read all about it. What we're going to do is we're going to use the string format instead. Okay, so if I want to print something out, right, I can say print line, it's string.format, and then in parentheses, I give it the string that I want to format. And what you get to do here is you get to put in a format string the same way you do with printf. But what you get back is a string result. So this string result here can then be printed if you want, or you can put it in a mobile application, or you can put that string in a web application, or you can put that string in a graphical user interface application, versus printf will only print to the console. So string.format is the more flexible version. That's the one we're going to practice and use. It's essentially printf, but you can use it everywhere. So what you do is you give it a string format. So we'll say lunch today is colon, and then I'm going to say %s for a string substitution. So the percent sign here is the substitute character. Anytime Java sees the percent sign, it's thinking it needs to substitute something. So we give it the string, and then we put a comma in, and we say other lunch choice. So for every substitution, you comma put in the thing you want to substitute in. Okay, so we should get the same result back out, right? Lunch today is, and now this is prettier, right, than having to concatenate, because you see the single quote here. And again, this one's not so bad because this just kind of goes at the end, but we'll look at some other examples in a minute here. 10, 10, 10, 10, 10. Lunch today is burger. Oh, look, I can't even spell today. Today. There we go. Today. Burger King. Okay, so that's nice, but this one's a little bit simple. But what if we had a slightly more complex case, right? What if we wanted to say, you have, so if you want to say a number here, there's two things. There's %d for digits, integer values. I hate %d digits. That's how I remember it, for integers. Or %f for floating point numbers, which are doubles and floats. So %f here, money for lunch. So lunch today is, and then now we have 2 % signs here. So I need to give it two things here. So after the comma, I'm going to give it two things. So the first one then will be lunch money. Then the next one will be other lunch choice for my string substitution here. So %f for floating point, %s for string. So let me bring this down a little bit here. Or here, maybe, how about that one? It doesn't quite fit. It's close. That's close. So you'll see, again, you give it the string to format, and then you give it these are arguments here. The format arguments. What am I going to plug into these places here? So now you can see this is nicer, lunch, than having to do the concatenation. Right? It's the exact same thing here as you have plus lunch money, plus money for lunch. So lunch today is, oh, we don't need this format then, right? Can back that out. Plus other lunch choice. Parenthesis, semicolon. So you can see like one of these is just a little bit easier to see once you get used to it. So it takes a minute. Hydration, thank you so much. Oh, am I out? I'm out. I gotta get more hydration. I'm in trouble. So this, like you're mixing and matching quoted strings, these literal strings with variables, and you kind of have to go back and forth, and you have to remember to make sure you have all your spaces in here. Either way, versus the substitution version is a single string, literal, with, hey, this is what I'm going to plug in. All right, let's give it a run, make sure we get the same thing. 10, 10, 10, 10, 10, 10. Ah, so the first version gave us this. The next version gave us this. We get a couple decimal places. So the other cool thing you can do with formatting here is you can tell it how many decimal places you want to round to. So if I say 0.2f, it will round to 2 decimal places. Don't memorize that. Just go look it up. Anytime you need to format a number with decimal places, go Google it. That's what I did. And I've done it too often now that I remember, unfortunately. But you should not remember. And now you get a nicely formatted here. So we could even add like a $sign, right? Wouldn't that be pretty? Add in the $sign here. And then it looks like we have pennies and cents. Or no, cents. Yeah, just cents. Not cents are pennies. 10, right? You have $10 money, sure, for lunch. So maybe we don't need to say money then, right? Because we have the $sign. Okay. So we can substitute here with the printf, or I'm sorry, string.format, which is better than printf. Works the same way here. All right. Yeah, %f is the substitute variable. So it tells Java, hey, when you see %f, go find the floating point value and plug it in. %s is the string, go find a string and plug it in. %d is for digits, go find the integer and plug it in, and you just do it in order. Okay, so %d for digits, %f for floating point numbers, %s for strings, and I think there's a couple other ones, but that's the only one we look at in the book so far, because that's plenty. Okay? So string.format is definitely the preferred method rather than printf, because this string you can use other places. Right? It's the same thing. So you say printf instead, and you give it this. That's one too many. Okay, printf works the same way, but string.format, right? We can you want to get used to using that one because it's going to be more useful later on. Oh, and printf does not give you new line characters. New line character. So you have to add in your own \n new line characters. Yeah, I think you put in 2, right? I think 2 of them. That makes sense. Let's try it and see. I don't know. I'd have to Google it if this doesn't work. Yep, 2 of them give you a % in a formatted string. Good question. Just like 2 backslashes, it gives you that escape character, right? So a backslash is the escape character. 2 backslashes gives you a backslash. That ought to do it. All right, folks, believe it or not, we finished the chapter, chapter 3. It is a lot of material, right? Chapter 2 is big, chapter 3 is big, and honestly, they don't get any smaller, right? Chapter 4 is big, chapter 5 is big, chapter 6 is big, and on and on and on. How far are we going to get here? I can remember all the chapter numbers. No, I can't. That's a lie. So let's take a peek. Right, it's all a lot of reading. So remember back in the syllabus quiz, it said for a 4-credit class, plan on 8 hours outside of lecture time for reading and quizzes and assignments and projects and all that stuff, it's a lot of reading time, right? Keeping up with the textbook. That is your main reference here. I'm trying to pull out the highlights, give you other examples, try and show you how these things work, talk you through them. No, that's actually all I have today. So go ahead and get working on Project 1 so you can have a good Memorial Day. 6/7, Project 1 is due. I'll post the quiz for Chapter 3 shortly. It'll be due 6/7 by 11:59 p.m. Again, I like to give you that last little bit. If you wanted to go over Chapter 1 quiz, let me know. Most of the time, people don't ask. So I was doing it, and then I felt like it was a waste of people's time because most people didn't care. Nope, so Project 1 is for this chapter. Project 2 will use Chapters 3 and 4 material. Project 3 will use Chapters 5 and 6 material. And the final project will use 7, 10, 12, and 13. Yep, I try and give projects that are 2 weeks. When I give projects that only had 1 week to get done, it didn't go quite as well. And then, I don't know. I find every other week for projects tends to be a better pace. Yeah, Project 1 is the only, if you're done with that, you're done then. So read Chapter 3, do the Chapter 3 quiz, that'll be your homework, Quinn. Yep, and then have a good Memorial Day. If you guys haven't tried barbecue jackfruit, it's fantastic. It's a really good pulled pork substitute. Barbecue jackfruit's really good. Just don't get your own jackfruit because it's a really big pain to process and it smells really funky. But like after someone else has processed it and you just slather it in barbecue sauce, it's just like pulled pork. It's amazing. So that's your barbecue pro tip there. All right, I've got the rest of the night. If you folks have questions, do let me know. And I do have office hours because a lot of people, you must like the evenings like I do, said 10 to 11 p.m. would be great for office hours. So I'll be hanging out tonight, 10 to 11 if you want to come on by as well, ask any questions. A lot of stores have it now. Maybe not all of them, but I've seen it at Meijer before. Kroger's had it before. Some of the smaller specialty stores have it, like Fresh Time, a small little chain. They've got it, but it's really good, really good. So one of my daughters has been vegetarian for probably 5 years now, so she likes that. And one of the other daughters wants to try and be a vegetarian, but she keeps going back and forth. And anytime we have chicken nuggets, she always eats them anyway. But she's trying hard. And then for reasons, every February I'll be vegetarian for a month. I've been doing it since I was a kid, like a teenager, and I thought it was fun. So pretty much every February I go vegetarian, and I look for stuff like that. So it's lots of fun. Yep. So we are officially out of our 15-week course, essentially. 3 weeks done. Right, that's 20% of the course is done as of tonight. Once you get your homework done. So this class flies. You've got to get into the reading, keep up, work on the projects. Again, I can't take Project 1 late. On June 7th, I'm going over the solution. So I can't take it late after that. All right? So get into the habit of getting those in on time. And we should be in good shape. All right, should we see if there's someone around on Twitch to raid? See who's around? Let me put it on my other screen here because trying to load that, it's really funny. And we'll have a lot of fun. You folks take care. It's been great. I'll see you in a little while. Let's see. Oh, boring math professor's around. He is actually not boring, despite what you might think. Boring math professor. PhD from some Ivy League school. He's super smart. Teaches a lot of calculus, other math classes. We'll go there, so everybody say hi. And you folks have a great night. Let me know if you have any questions. All right, take care, everybody.
Male, chicken, pickle, but it's